So, here we go with our set theory solutions. The most important thing to remember when filling in a Venn diagram is not to think in terms of sets, but to think in terms of areas on the Venn diagram. This outer area over here is everything outside the sets B and L. And this inner area in the middle is everything that is in both sets B and L. This area over here is for things which are only in set B, and this area over here is for things which are only in set L. And the only numbers they give me from the 20, the 6, 7 and 9 that I can fill in straight away are those that fit exactly into one of those categories. So I can't put the number 20 onto the Venn diagram, but the 4 numbers I do fill into the Venn diagram are going to add up to 20. The number 6 refers to the number in set B, and I can't put 6 onto the Venn diagram because it's going to be shared between these 2 points. Similarly, I can't put the number 7 into the Venn diagram because that's going to be shared between these 2 points over here. The number 9, however, can be filled into the Venn diagram. 9 trucks passed the tests for both brakes and lights. Now, these sets refer to trucks failing tests. The 9, therefore, goes out here. That means, in total, these 3 dots over here, those 3 dots in the middle, have to add up to make 11, because the total number of trucks being tested is 20. Now, the 6 that belong in here, plus the 7 that belong in here, altogether that makes 13, and we're only allowed to fit 11 into here. That means 2 of them must go in the middle and be shared between the 2 sets. If there are 6 altogether in set B, that means with 2 over here there must be 4 in this side, and with 7 altogether in set L, there must be 5 over here. And let's just quickly double check. I've got 9 plus 4 plus 2 plus 5, and that makes 20. So there's my complete the Venn diagram bit, and now we have to interpret this statement over here. Let's first of all consider what's meant by B dash and then the intersection symbol L dash. This is everything which is not in B and not in L. Now the easiest way to do this is to simply test each of these 4 regions for this condition. If I look at the outside of those 2 sets, this satisfies the condition that we are not in B, and it satisfies the condition that we're not in L. So I would want to include that area. None of these 3 areas here satisfy those conditions. We are either in B or in L, so we cannot possibly satisfy the condition that we are both not in B and not in L. In other words, the only part of this Venn diagram that satisfies that condition is what's outside of those 2 sets. The little n asks for the number of elements which are in this region, and so that's just going to be 9. Let's move on. So we have quite a complicated looking request over here to shade a region given by P union Q intersect Q dash. So we're trying to satisfy 2 conditions at the same time. Condition 1 is that we must be in P or Q. Condition 2 is that we must be not in Q. Because we're using this symbol, the intersection symbol, we must satisfy both of these conditions. Now to be in P or Q, the union of P and Q, that would be everything contained within both of those sets, like this. And to not be in Q is fairly obvious, we can't be in Q. So I have 4 regions to check. This region out here, that satisfies the condition that we're not in Q, but it doesn't satisfy the condition that we're in P or Q, so it does not get included in my shading. This region over here satisfies that we are in P or Q, and it satisfies that we're not in Q, so I would include that region. The next two regions don't satisfy the condition that we're not in Q, and since I have to satisfy both of these conditions, I know they can't be included in my shading. And so I go ahead and shade just this part of the Venn diagram. This is a very, very nice way to do these shading questions, to identify specific regions on a Venn diagram. Just go through and test each area under the conditions. And we're going to apply that same idea now to the next question. I'm asked to shade the region A or B dash. So condition 1 is that we have to be in A. And condition 2 is that I have to not be in B, not in B. Because those conditions are being combined with the union symbol, as long as I satisfy either one of them, I get to shade that region. So there are 4 areas to test. Let's look at this outer area first. That satisfies the condition that I'm not in B. It does not satisfy the condition that I'm in A, but that doesn't matter because I get to shade it if I satisfy either or of those conditions. So that one gets a tick. This next region over here is in A, and it's not in B. I've satisfied both conditions, even though I only needed to satisfy one of them. The next region along satisfies the condition that we are in A. It does not satisfy the condition that I'm not in B, but that doesn't matter because I only have to satisfy one of these conditions. Looking at the last area, this is not in A, and it is in B. It doesn't satisfy either of my conditions, so it would not get shaded. So this entire Venn diagram is going to get shaded, with the exception of that little crescent moon that's in B. Let's have a look at the next one. I have 2 conditions. Condition 1 is that I'm not in A. And condition 2 is that I'm in B. But this time these conditions are being combined with the intersection symbol, which means I must satisfy both of them if I want to shade that area. Let's look at this outer area first. That is not in A, so it satisfies the first condition, but it's also not in B, so it doesn't satisfy the second condition. And because with the intersection symbol I must satisfy both conditions, I don't get to shade it. The next area is in A, so it fails the first condition. It also fails the second condition, so it gets across. The next area is also in A, and seeing as I failed one of the conditions, it gets across straight away. Finally, this area. This is not in A and it's in B. I have satisfied both conditions, so this area gets shaded. Another shading question, 2 conditions. I have to be in F and I have to be not in G. Because they're being combined with the union symbol, I can shade an area that satisfies either one of these conditions. So if we have a look at this outer area, that's not in G, so I've satisfied one of the conditions, I get to shade it. This next one is in F, and it's not in G, so I definitely shade that one. This next one is also in F. It fails the condition that's not in G, but it doesn't matter because this symbol only needs one or the other, it doesn't need both. And finally, this final area is not in F, it fails the first condition, and it is in G, so it fails that condition as well, and doesn't get shaded. So I would now shade my Venn diagram, leaving out that crescent shape again. Now we have a different sort of a question, 3 circles in my Venn diagram, 3 sets in my Venn diagram, and I'm being asked to arrange elements in that diagram. Now you will often see questions where sets are given in terms of a rule rather than in terms of a list, and it's usually a pretty good idea to make a list out of the rule. This first set is the universal set, and those are all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 that exist for this Venn diagram. All those numbers have to be placed within the rectangle by the time we're done. So set A is x such that x is an odd number? So I'm going to take the odd numbers from the universal set, and that makes set A. That's 1, 3, 5, 7, and 9. Square numbers from the set A, that's 1, 4, and 9. And multiples of 3 from that universal set, that's 3, 6, and 9. A lot of the time these set theory questions also test your knowledge of things like odd numbers, square numbers, prime numbers, and so on. Right, so what I'm going to do now is I'm going to look at the universal set and decide where to place each number. So I'm going to start off by placing the number 1. 1 is in sets A and B, but not in set C. So the area of the Venn diagram, which is A and B, but not C, is this little spot over here. Now I'm going to place the number 2. 2 doesn't appear in any of the 3 sets A, B, and C, so it must go on the outside. The number 3 is in sets A and C, but not in B. So A and C, but not in B, that's going to be over here. 4 is only in set B, and that's going to place us over here. This is the part of set B that is just B and doesn't share any overlap with A or B or C. A or C, sorry. The number 5 is only in set A, and the number 6 is only in set C. 7 only appears in set A, and 8 doesn't appear in any of these sets. 9 appears in all of them, so that goes in the middle. So the approach here is to actually take the numbers in the universal set and go in order, checking off which sets they belong in until you've run out of numbers. Now we're going to include another number in the universal set. This is in the region not A and B and C. So we're looking for a part of this Venn diagram which satisfies that condition. We must not be in A. We must be in B, and we must be in C. So we're looking over here at this part of the Venn diagram. That's in B and C, and it's not in A. I want a possible value for this number, so I need to go back to the definitions of A, B, and C. Now, to be in both B and C, we must be a square number that's a multiple of 3. Obviously, one example of this is 9, but we want to look for something a little bit bigger, perhaps. It also can't be an odd number. So I start thinking about my square numbers. They're also multiples of 3. Going past 9, we've got the next square number is 16. Well, that's not a multiple of 3. 25, that's not a multiple of 3. But then we hit 36, which is 6 squared. So 36 satisfies the condition that it's a square number, it satisfies the condition that it's a multiple of 3, and it satisfies the condition that it's not an odd number. So I could use 36. Incidentally, 0 would also work. 0 is a multiple of 3. It's 3 times 0. 0 is also a square number. 0 squared is 0. But it's not an odd number. Technically, it's an even number. So you could use 0 as well. So here's another question. We've got a universal set of all the students in a particular class. P is the students who study physics, and C is the students who study chemistry. And here's a Venn diagram showing the students. I want to find the number of students who study physics or chemistry. Remember, in maths, or includes and. This is different to how we tend to use or in everyday language. If I tell you you can have the chocolate cake or the carrot cake, you assume that you can only pick one or the other. But when we use or in maths, we're allowed to pick both. So if you ask a mathematician if they want the chocolate cake or the carrot cake, they'll feel quite happy picking up a slice of both and think that's fine. So the number of students who study physics or chemistry, that is going to be 5 plus 11 plus 8. And that's going to give us 25 students. And that will be our answer over here. I've actually done my adding up wrong there, of course. 5 plus 11 plus 8 is not 25, it's 24. That'll do. Now I want to know the number of students who satisfy this condition. They are in set P, and at the same time they must satisfy both conditions. They are not in C. So with 4 regions to look at, this is not in P. It fails the first condition. I have to satisfy both, so it wouldn't get looked at. This region over here is in P and it's not in C, so I'm happy with that region. Both of these regions would fail because they are in C, and I have to satisfy both of these two conditions. So the number of students, remember n looks for the number of elements, the number of students who satisfy that condition is 5. Now sometimes your set theory questions will turn into probability questions. A student who does not study chemistry is chosen at random. We want to find out the probability that this student does not study physics. So let's read this statement very carefully. We are choosing from this class a student who does not study chemistry. So we have 12 students to choose from. Whatever our choice is, it's out of 12. The probability this student does not study physics, well, there's 7 of those 12 students who don't study physics, so our probability is 7 out of 12. This is pretty straightforward to do, but we have to read the question very carefully. And I'll continue on with the rest of the solutions in the next video.